This is another exponentials and logarithms question. It's not too bad. As usual, give this question a go first. I will give hints at the beginning of each part, so you can skip ahead to see those. So for part A, we're told that the temperature theta of a cup of tea t minutes after it was placed on a table in a room is modeled by this equation. So we're told that theta is equal to 18 plus 65 e to the minus t over 8. We're told that t is greater than or equal to 0, which makes sense because t is time. And the question says, find according to the model the temperature of the cup of tea when it was placed on the table. This shouldn't be too hard. Trying to think about what t would be when you place the cup of tea on the table and use that to work out theta. So t would be 0. Put that into our equation. 18 will be equal to, or theta will be equal to 18 plus 65 e to the power of 0. E to the 0 is 1, so this just becomes 18 plus 65, which is 83. Part B. The value of t to one decimal place when the temperature of the cup is 35 degrees Celsius. So theta is equal to 35 degrees Celsius. We're trying to work out what t is. So you want to put that into this equation and then rearrange for t. So then we will get 35 is equal to 18 plus 65 e to the minus t over 8. We can rearrange this, so bring the 18 to the other side. 35 minus 18 is 17. Divide both sides by 65. And now to get rid of the e, we do natural logs of both sides. Natural log is the same thing as just log to the base e. And then so the ln and the e cancel, and then we get minus t over 8 is equal to ln 17 over 65. So then we end up with t is minus 8 ln 17 over 65, which will be 10.7. And the unit for time is minutes, so 10.7 minutes. And that is part B. So part C is when it starts to get a little bit trickier. So explain why, according to this model, the temperature of the cup of tea could not fall to 15 degrees Celsius. So we know what our equation is. It's 18 plus 65 e to the minus t over 8. I'll write that down here. So for this, we want to think about, what does a graph of this look like? What does a graph of that look like? Think about things like what happens when t gets bigger. Think about things like where the asymptote would be. And then hopefully you should be able to solve part C. So with these kinds of graphs where you have exponential graphs that have been translated or transformed in different ways, so we have stretches, we have shifts or translations, reflections as well. If you think about the different kinds of graphs that you can possibly have, or if we think about that, so we know that this is a normal e to the power of x graph, where this is 0, 1. So you can stretch this horizontally, which doesn't change the asymptote, which is y is equal to 0. It doesn't change what the y-intercept would be, which would be 1. So horizontal stretches don't really change too much of the graph in terms of the key points and asymptotes. If you were to multiply the graph by something, if you multiply e to the power of x by something, then you'll end up changing what the y-intercept would be. We could also reflect this graph in the x-axis, or we could reflect it in the y-axis. That's another option for how this graph could evolve. And you could also shift the graph up or down, so it could look something like, if this is your x-axis, we could have our asymptote be shifted upwards, and then the graph could look something like this. And that's what happens when you add a number to the exponential. So there's a variety of graphs which you could have. Maybe you have an asymptote like this, and then the graph approaches the asymptote like that. So then, if we know that those are the kinds of shapes that we can get for exponential graphs, then what we can think about here is, well, what does the easiest way to then figure out what our graph would be, rather than to go through the whole sequence of transformations, which is a useful exercise to be able to do, or to have that skill. We could think about what theta would be when t is equal to 0. So we could start with that. Put in t is equal to 0 into this equation. We end up with theta is equal to, as from earlier, we got theta was equal to 83. So we know that our graph starts at 83. And then the question is, well, is it rising or is it falling? And how is it falling? Is it falling like this, or is it falling like this? Well, then you can figure that out by what happens to theta when t gets bigger and bigger. So if you think about as temperature approaches infinity, what happens to theta? So if you look at, actually, if I first consider the e to the minus t over 8, as t gets bigger and bigger and bigger, e to the minus t over 8, it approaches 0. And we can see that because e to the minus t over 8 is a graph that looks like this. It's like e to the minus x, which is a reflection of the graph e to the x in the y-axis. So if e to the minus t over 8 looks like that, we can see why it approaches 0 as t gets bigger and bigger. And that then means that we will have theta approaching 18 as t gets bigger and bigger. So theta approaches 18. We know it's therefore not going to look like this because, well, that's not approaching 18, that's just going all the way down to negative infinity. Our graph should then look something like this, where we have an asymptote where theta is equal to 18. That's the equation of that asymptote. This is the theta axis, which is the y-axis, and the x-axis is, in this case, t. So that's what our graph looks like. Theta approaches 18. And that should suffice for our explanation. So if we say something, if our working were to be something like this, as t approaches infinity, theta approaches 18 from above, we could say, or like it approaches 18 from 83 degrees, then that should be enough for part C. So on to part D. Okay, so we have a graph, mu against t. We're given some coordinates. There's an asymptote. It's a second cup of tea. We're given an equation for our graph. So I'll write that down. So mu is equal to a plus b e to the minus t over 8. And we're told that t is greater than or equal to 0. So we're told that a and b are constants. So a and b are the constants. Mu and t are the variables. And yep, we're told that there is an asymptote. Right, so use this equation to figure out the equation of the asymptote for L. Right, so if we think about the previous question, so here's the hint for this part, for part D. If we think about the previous question, where we had this equation, notice what the asymptote was in that case. Remember that the plus 18, that's what shifts the graph up by 18 places. So the asymptote is usually at y is equal to 0 or theta is equal to 0. Adding 18 moves everything up, including that asymptote, to theta is equal to 18 in this case. So think about what the asymptote would be here. We need to work out what a and b are, so we can use these coordinates to do so. So give that a go. So let's start by putting in the 0.94 into our equation. So mu is 94, t is 0, so a plus b e to the power of 0, which is just 1. So our first equation is then a plus b is equal to 94. I'll call that equation 1. And our next equation, our other coordinate, is 850. So 50 is mu. That's equal to a plus b e to the minus 8 over 8, or e to the minus 1. And e to the minus 1 is the same thing as 0.36788. So this equation becomes a plus 0.36788 b is equal to 50. I'll call that equation 2. So then we need to solve these two things simultaneously. So I write one on top of the other. So a plus b is equal to 94. And then we have a plus 0.36788b is equal to 50. We'll take away the two equations. The a's cancel out. These two, one take away from the other. So b minus 0.36788b would give us 0.63212b, and then 94 minus 50 gives us 44. And then so then b would then be 44 divided by 0.63212, which gives us 69.6. And then a, it would be equal to, if we look at this equation here, equation 1, a is equal to 94 minus b. So 94 minus 69.6, which ends up being 24.4. So a is 24.4. So our equation is then mu is equal to 24.4, which is a, plus b, where b is 69.6, e to the power of minus t of rate. And then if you think about what we did in the previous part, if we're adding 18, our asymptote becomes theta is equal to 18. So in this case, we're adding 24. Our asymptote then becomes mu is equal to 24.4. And that is our answer.